Now we're going to switch gears here and look at an overview of a digital health um, ecosystem overview, right? We're going to look at that infrastructure overview, and then we will look at a major health information system through an architectural lens. Now, if now evaluating a health system through an architectural lens, that's how an informaticist must look at the health system he or she is building, is architecting. Now, my guiding question is, how should an informaticist evaluate any health information system? Remember, we're not talking of technology here. Technology comes after you've looked at the needs of the organization and after you've looked at evaluated series and series of pertinent factors. And so um, I came up with this architectural evaluation framework, right? And the first thing there is a four architectural responsibility framework. And so for every health system you're trying to architect, you're trying to build, there are four questions you need to ask. What information does this create? What are you expecting from this system, right? What is the output? What information does it create? What information does it consume? What is your input? What information input goes into this system? And what systems must it communicate with? And what decisions depend on its information? Now, these four questions shift the conversation and shift the focus from the technology. It shifts the focus from the software features to the architectural value. So it's no more a question of what EHR are we going to implement? What um, um, radiology system are we going to implement? Those are secondary questions. The primary questions are these four questions. What are you looking to do? What is your output? What is your input? Right? What do you expect this to do? Who do you expect to use this system? How do you expect them to use this system? And what decisions depend on its information? Now, this framework provides a method for analyzing any digital health application, and we will use it throughout this course and in professional practice. Now, let's look at the components of a digital health system. Now, we've ascertained that it's okay. It's, in fact, a good thing to have different systems that do different things with different areas in their different areas. So long as they are all connected together and they talk to each other together, they are scalable, they are secure, they are current, we've ascertained those are that's correct, right? But looking at the component of the digital health system. Now, the first thing or the major system that jumps out at us is the EHR, right? That's the everybody looks at that as this is, in fact, for most people, if you ask them, the EHR, electronic health record, is the digital health ecosystem itself. But that's incorrect because as we saw before, the EHR it's only one part of that ecosystem. Yes, an important part. In fact, some people have described it as being the heart of a digital health system. And sometimes I use that too, even though that analogy can be misleading, right? When you um, uh, say it's the heart, you are assuming that, or you are implying, not assuming, you are implying that just like the heart in the human pumps blood to every part of the body, right? That the EHR pumps information and data to all the other systems. But that's not the way it actually works, right? That's not the way it actually works because the radiology information system does not depend on its own appendage, right? It's they are all connected, but each of them doing their own thing. In fact, a more accurate description will be that it functions as an integration platform, so to say, right? Its role is to present clinicians and users with a comprehensive longitudinal view of the patient's health by bringing together information from all these specialized systems. It's important, I must add, that the EHR does not and should not attempt to replace every departmental applications. The labs still require their system because that's designed for their workflow, right? The pharmacies still need a way to manage their inventory and medication verification. The EHR is not equipped to do that. Radiology departments still manage their imaging acquisition and storage, huge files when we talk of storage, and obviously very high resolution because they need to be interpreted. Now, these operational responsibilities are best handled by specialized systems and not the EHR. However, however, the EHR is at the center of this, and it creates a shared clinical context, right? In which healthcare professionals can understand what's going on in the patient history, current condition, ongoing treatments, and future plans by looking at the imaging results, by looking at um, um, lab results, right? So the EHR, what it does is to provide a clinical context by pulling all this information together. So for the electronic health records, what you're looking at is the information dependencies. We've said that the EHR provides clinical context, by tying together the activities of other systems, right? So if you look at this, the slide we have here, the types of information that is created, so the clinical documentation, the diagnosis, patient problem list, allergies, and all that. Now, what information does it consume? Patient registration, that's done in the registration module, right? Lab results, that's done um, um, in the lab system. Radiology reports, that's done in the radiology information system, right? And I should point out the lab system, radiology system, the pharmacy system, those may be connected to the EHR, but those are not EHR. Now, if this isn't done right, if this integration is not done right, the integration between the electronic health record system and the other specialized systems, challenges arise, right? So you then you have duplication of patient identities. Then you have because you may have a patient registered in the patient registration system, but then you go to the lab and then do the same registration. That's a duplication that creates unnecessary redundancies. And they delay, you may also have a delayed lab interface. You may have inconsistent terminology. We looked at this during our second course when we studied standards. So, like we said earlier on, the electronic health record does not own all clinical information. Rather, what it does is effectively connect all the other systems, right? It is the integration platform. It doesn't own that information, but it has the ability to pull all that information onto itself and present it with context as a longitudinal record of the patient to the user. The EHR does not replace these other specialized systems. And we must recognize that the electronic health record's true value is in being able to orchestrate this information. And its effectiveness is on being able to ensure and present information in a timely manner from the other enterprise systems. So, from an architectural perspective, the EHR is valuable because it coordinates information, not because it contains every operational detail. This distinction is important and fundamental to understanding enterprise health architecture. Now, in addition to the electronic health system, in a digital health ecosystem, there is a lab information system, right? Um, Oftentimes, people say this is the enterprise source of diagnostic truth, and that's what it is, right? Many times, the providers won't even start treating their patients until they get the results of the maybe the labs or the lab tests or the diagnostic tests. Now, the lab systems are often among the earliest digital systems implemented in hospitals because their operations are highly structured and transaction intensive. Even though it's connected to the electronic health system, but we know that architecturally they are independent from the electronic health system. So our slide shows the architectural responsibilities of a lab information system. So one of those responsibilities is that there's order management. It receives and manages lab requests. There's specimen life cycle. It tracks and collects and transports and processes and stores specimens. Result verification ensures analytical accuracy before release and all that. So, from an architectural perspective, a design rationale should be that labs, because laboratories generate thousands of highly structured transactions daily, their operations are very complex, right? And it requires specialized workflow that extend beyond the capabilities of the general purpose EHR. And that answers our guiding question. And that is why laboratory systems are typically architectural independent, from the e- typical EHR. Now, looking at the information dependencies for the lab information system. What information is created here? So we have verified lab results, we have specimen status, we have quality indicators, and lab utilization metrics. What information is consumed? Patient identifiers, clinical orders, tests requests, and provider information. Now we should point out that without effective integration, in other words, without efficient architecting of the health systems, the results may reach clinicians too late. There may be duplicate tests, which obviously, because the patient needs to pay for it, would increase costs. Critical values may not trigger alerts because they're late. Public health surveillance may be delayed. And so the decision makers will have incomplete data when they're making decisions. And research databases or data sets become incomplete. The third component of our digital health system, enterprise digital health system, is the pharmacy information system because this manages medications across the enterprise, right? And we have architectural responsibilities here, just like the last one. Because again, remember those four questions. What information does this system consume? What does it need to do its job? What is it producing? What is the output? What information does it output? Who uses it? And how is it used? Okay. So medication information um, extends beyond prescribing. It connects clinical care, patient safety, inventory management, procurement, finance, and even public health. The pharmacy information system coordinates these interconnected processes. Now, unlike the EHR, which documents prescribing decisions, the pharmacy system ensures not just that the medications are available, talk of inventory, that they are safely dispensed and appropriately tracked throughout their life cycle. So, medication management is a prime example of why of a single information domain or system that can serve multiple organizational roles or functions, right? Because think about it. A prescription initiated by a clinician triggers a chain of activities involving pharmacy verification, dispensing. We don't have these medication anymore. They do their inventory adjustment, right? We have to bill for this. They do their financial charging, right? So each step generates information that supports decision beyond what you have at the bedside. And looking at the information dependencies for the pharmacy information system, again, what information is created, what is consumed. So we create the dispensing records, we create the inventory status, we create the medication utilization data, we create, very importantly, adverse event documentation. But what is consumed? The electronic prescriptions that are usually done in the EHR, the patient allergies to those medications that are given that are usually documented in the EHR, right? So again, um, as an architect, you're looking at where is this information generated? Where is it going to be used? To make sure that for both systems, what they need is always available in terms of information. That's your role as a systems architect. The last component we're going to look at is the imaging systems, right? Um, and I'm going to ask again, why does the medical imaging require a different architectural approach from other clinical information? The size of the data they generate. Let's think about it. You're looking at basically pictures, huge files, right? So their storage requirements are different. So imaging informatics presents, I mean, unique architectural demand, right? Because while other systems may generate text, this system generates medical images, and that's significantly different from lab results or medication results or clinical results, right? So high resolution images, I mean, they consume a substantial amount of storage and require huge bandwidth. And so they require specialized infrastructure and retrieval mechanisms. So systems like radiology information systems, the RIS, or the PACS, picture archiving and communication systems, PACS, they separate workflow management from image storage, while integrating with the EHR to provide clinical context. So a mature architecture ensures that both the images and the reports are available whenever clinical decisions are made. Just like the other systems, the information dependencies here also exist, right? So the imaging information supports the clinical diagnosis, the surgical planning, oncology staging, and all the rest of it. And if this isn't done right, if that integration isn't done right, if the architectural planning isn't done right, right, then you have medication discrepancies. you can have medication discrepancies because remember, if these systems are supposed to be connected and they rely on information from the other systems in real time, if that doesn't happen, then obviously you have challenges. And looking at the imaging pathway for um, a race or a PAX, right? You can see on the diagram that the pathway is from, first of all, you place your order, right? To um, to insight across the system. So that you place your order, there's the workflow, there's modality acquisition, maybe it's an MRI or something. Then that image gets stored at a server somewhere, right? And then the radiologist pulls it up on his computer, high resolution image, obviously, and does the interpretation, and then documents their finding in the EHR. So, from the informaticist perspective, the goal is not simply to store the images. The goal is to make sure that the imaging knowledge is available in the EHR when and where is needed without compromising the performance, the clarity, the security, or the workflow or the clinical workflow.